Hi guys, welcome back to my YouTube channel. So today's topic is compass survey. We are going to study about the different types of survey that is included in the compass survey. So there are mainly the two types of traverse. They are the closed traverse and the open traverse. So traverse, in surveying, a traverse consists of a series of straight lines connected together to form an open or closed polygon. Such as the closed traverse are like this, in which we know the stations, starting stations and ending, such as A, B, C, D, E, F. This is a closed traverse. This is a closed traverse. In closed traverse, we know both the starting and the ending point. It starts from one station and close to the same station whose location is already known in this closed traverse, whereas in open traverse we start from one station and close at another station whose location is neither known and nor established, such as this is open traverse. This is station A, this is B, this is C, this is station D, and this is E, whose location is not established. Okay, so this is open traverse. We generally confused between open traverse and linked traverse, but linked traverse looks like same as open traverse, but in linked traverse we know the starting point and the ending point, such as this is a linked traverse where this is A, B, this is C, this is D, and this point is E. So the both locations are already known, and we can also use another stations from this point to calculate for surveying. So the reader must be very clear to find out the difference between this open traverse and the linked traverse. Although both are geometrically open polygons, but the linked traverse is mathematically closed. So this is linked traverse. So now we will today solve about this closed traverse. Okay. Here in a closed traverse, if the traverse stations are going in a closed direction, then we will calculate its exterior angle, such as this is a closed traverse which stations are going in a closed direction. So we are going from A to F in a clockwise direction. So this is clockwise direction. Okay, we are going in a clockwise direction, and there will be stations in which we will go in anti-clockwise direction, such as this A, B, C, D, E, and F. So here we are going anti-clockwise direction. Anti-clockwise. We will calculate in anti-clockwise direction interior angle. So here for the clockwise direction we will calculate exterior angle for the stations, and for anti-clockwise direction we will calculate the interior angle. So the sum of exterior angle is equal to 2n plus 4 into 90 degree. So this is a theoretical sum, and sum of interior angle is equal to 2n minus 4 into 90 degree. So you guys can just screenshot this page. Okay, that will be easy for you to solve another questions. Now how do we calculate the fore bearing and the back bearing? So here, for example, we have the formula fore bearing of AB is equal to let theta 1. So fore bearing of BC is equal to, so let this is fore bearing and this is fore bearing of AB, and this is back bearing of AB. This angle from north to here, the preceding line is back bearing. So forebearing is the horizontal angle in clockwise direction which a line make with a knot and end of reference meridian in the direction of progression of a survey line, whereas back bearing is defined as the horizontal angle in clockwise direction which a line make with a knot end of a reference meridian in the direction opposite of the progress of survey. So this total is the back bearing and this is forebearing. So we have forebearing of AB, let this is theta 1 is equal to theta 1. So back bearing of BC will be this angle, forebearing of AB plus angle B, in which we are calculating this angle, in which station we are here, angle B minus plus minus 180 degree. So plus minus we use when if it is greater, this both is greater than 180 degree, then we will subtract 180 degree, and if it will be less than 180 degree, then we will add 180 degree. Now back bearing of BC will be equal to forebearing of BC plus minus 180 degree. And with so this is a formula, this is a simple formula which we will be used while solving the numerical, and you will guys see the use of this formula in the upcoming numerical that we will going to solve in today's video. So here is a numerical based on the closed traverse. So the given question is to here the following bearing was observed in a compass traverse. The lines are given, forebearing and back bearing of the respective lines are given here. So we have asked at which of these stations would local attraction be suspected. So local attraction is the attraction of the magnetic needle with the local magnetic field rather than the earth magnetic field, and we can detect the local attraction by observing this forebearing and back bearing. If the difference between this forebearing and back bearing is 180 degree, then it is free from the local attraction, else it has some error and we have to solve and correct that. Okay, so now we will solve and we have to also find the corrected bearing of these lines. Now we will solve this numerical. So here solutions, these are the line AB, BC, CD, DE and EA. This is forebearing, that is 69 degree 30 minute, 191 degree 30 minute, 230 degree 15 minute. So now we will calculate the difference between the forebearing and back bearing. Here the difference is 246 degree minus 69 degree 30 minute, that is 176 degree 0 minute and 0 second. So now 191 degree 30 minute minus 13 degree is 178 degree 30 minute. Similarly 230 degree 15 minute minus 53 degree is 177 degree 15 minute. Now 262 degree 45 minute minus 80 degree 45 minute is 182 degree 0 minute. Similarly 210 degree 30 minute minus 32 degree 15 minute is 178 degree 15 minutes. So none of the difference is exactly 180 degree here, so no line is error free, but the difference between the forebearing and back bearing of BC is nearly equal to 180 degree. So it is the most closer one to 180 degree, so it has the least error. This has least error. The difference is, so now here we have to give a proper explanation here. None of difference is 180 degree, so no line is error free, but the difference in forebearing and back bearing of BC is closer to 180 degree, so it has least error. The difference can be made 180 degree by, so the difference can be made by 180 degree minus 178 degree 30 minute, which is equal to minus 180 degree minus 178 degree 30 minute is 1 degree 30 minute. So this is the only difference by 180 degree is due to this 1 degree 30 minute local attraction here. So now we will divide 1 degree 30 minute in both forebearing and back bearing. So we have to divide in both forebearing and back bearing. we will divide by 2. That will be 0 degree 45 minutes. 0 degree 45 minute. So we will add 0 degree 45 minute to 4 bearing and this 4 bearing and back bearing of a line BC. So we will add and subtract in this 4 bearing in back bearing in such a way that the difference will be 180 degree. So here adding 0 degree 45 minute to 4 bearing and subtracting 0 degree 45 minute to back bearing. So now corrected 4 bearing of BC is equal to, here BC is 191 degree 30 minute. We will add this 0 degree 45 minute. So that will be 191 degree 30 minute plus 0 degree 45 minute. That will be 192 degree 15 minutes. So here 191 degree 30 minute plus 0 degree 45 minute is equal to 192 degree 15 minute. Now corrected back bearing of BC is equal to, so we have corrected back bearing is 13 degree 0 minute. So 13 degree 0 minute minus 0 degree 45 minute is equal to 13 degree plus 0 degree 45 minute will be 13 degree 45 minute. Now the difference between these two is 192 degree 15 minute minus 13 degree 45 minute is 13 degree minus 0 degree 45 minute is 12 degree. This is 12 degree and 15 minute. So now the difference between the 4 bearing and back bearing is 180 degree here. Okay. So now we will draw a rough sketch of the traverse of the given lines. So here we will draw a rough sketch of traverse. So the 4 bearing of AB, 4 bearing of, let us consider this is station A. So this is north AB. The 4 bearing of AB is 69 degree 30 minutes. So 69 degree must lies in the first quadrant, since this we can measure up to 90 degree in the first quadrant. So 69 degree must be here. This is station A. So let us consider we measure from the north with respect to north. So 0 degree it comes like 0 degree up to 90 degree. This is up to 180 degree. This is 270 degree and the round completes at 360 degree here. So 69 degree must be here. This is just a rough sketch. This is 69 degree 30 minute. Now this is station B. This is station B. So the back bearing of AB is 246 degree 30 minutes. So this is 246 degree 30 minute. Now the 4 bearing of BC. The 4 bearing of BC is 191 degree 30 minute. So 191 degree must lies between these. So this is 100. This is C. This is 191 degree 30 minute. This is station C and the back bearing of BC is 13 degree. So this is 13 degree. Now the 4 bearing of CD. The 4 bearing of CD is 230 degree 15 minute. So 230 degree must lies here. This is 230 degree 15 minute. This is station D. So the back bearing of CD is 53 degree. So this is 53 degree. Now the 4 bearing of DE is 262 degree 45 minute. So it must be here. This is 262 degree 45 minute. This is station E and the back bearing of DE is 80 degree 45 minute. So this is 80 degree 45 minute. Now the 4 bearing of EA is 32 degree 15 minute. So 30 bearing of EA is 32 degree 15 minute and the back bearing of EA is 210 degree 30 minute. So it must lies here and here. So this is 210 degree 30 minute and this is 32 degree 15 minute. This is the rough sketch of a traverse. Now we will solve a further problem. So for the clockwise direction, here this is going clockwise direction. The given here is going in clockwise direction. So we will calculate the exterior angle, and the sum of exterior angle is 2n plus 4 into 90 degree, where n is the number of stations. So here now for clockwise direction we have, so here since this is the clockwise direction, we will calculate the exterior angle. So the exterior angles are angle A. So angle A is equal to, so this is just a simple mathematical calculation that we have studied in a geometry in school. So here angle A, so the exterior angle must be this, okay, this remaining. So for that, if we will subtract 69 degree 30 minutes this angle from this total 210 degree, then we will get the remaining angle up to here. And if we will subtract this angle from 360 degree, then we will get the exterior angle A. So for that, here 360 degree minus this whole 210 degree 30 minute minus 69 degree 30 minute, we will get the exterior angle A. So here 360 degree minus 210 degree 30 minute minus 69 degree 30 minute, that will be 290 degree. Similarly, angle B is equal to this 360 degree minus subtracting 191 degree 30 minutes minus this 246 30 degree. So 246 degree 30 minute minus 191 degree 30 minute, which will be equal to 360 degree minus 246 degree 30 minute minus 191 degree 30 minute, that is 305 degree 0 minute. Okay, now angle C. So here for angle C we have exterior angle only this. This is the exterior angle. So to calculate the exterior angle, we will simply subtract this 13 degree minus 230 degree 15 minute. We will get the exterior angle of C. So here 230 degree 15 minute minus 13 degree is equal to 217 degree 15 minute. Now for angle D, similarly for angle D we will subtract 53 degree from 262 degree 45 minutes, which will be equal to 262 degree 45 minutes minus 53 degree is 209 degree 45 minute. Now for angle E, we have the exterior angle here is this. This is the exterior angle. So we have to subtract 360 degree. So here 300, we have to subtract this angle from 360 degree. 360 degree minus 32 degree 15 minutes from 80 degree 45 minutes. So 80 degree 45 minutes minus 32 degree 15 minutes, which will be equal to so this is 3. So now here the observed sum of the exterior angle is 290 degree plus 305 degree plus 217 degree 15 minutes plus 209 degree 45 minutes plus 311 degree and 30 minutes. So the summation is 1262 degree 30 minute. Now we will calculate the theoretical sum of the exterior angle, that is 2n plus 4 into 90 degree. So here theoretical sum of angle is equal to 2n plus 4 into 90 degree. So here number of station is 5. So 2 into 5 plus 4 into 90 degree is 1260 degree. So we have formula for error. Error is equal to observation minus theoretical value, which is equal to 1262 degree 30 minutes minus 1260, that is 1262 degree 30 minutes minus 1260 degree, that is 2 degree 30 minute. Now since the error is positive, so the correction will be negative. Since here the error is positive, so correction will be negative, and vice versa we will do, and vice versa. So now correction in each angle. So correction in each angle is equal to minus 2 degree 30 minute divided by number of stations, that is 5. All the stations are affected here. So 2 degree 30 minute divided by 5 is 0 minus 0 degree 30 minute. So now the corrected interior angles will be the corrected exterior angles will be corrected exterior angles will be angle A is equal to subtracting 0 degree 30 minutes from each angle. So angle A is here degree minus 0 degree 30 minute is 218 degree 30 minute. Angle B is 305 degree. So 305 degree minus 0 degree 30 minute is 305 degree minus 0 degree 30 minute is equal to 304 degree 30 minute. Now angle C is equal to 217 degree 15 minute minus 0 degree 30 minute. 216 degree 45 minute. Angle D is equal to 209 degree 45 minute minus 0 degree 30 minute is equal to 209 degree 15 minute. Angle E is equal to 311 degree 30 minute minus 0 degree 30 minute, which will equal to 311 degree. So now the sum of the corrected exterior angle is 280 degree 30 minute plus 304 degree 30 minute 55 minute plus 209 degree 15 minute plus 311 degree, that is 1260 degree. So this is corrected, checked. Now the corrected, we have corrected the exterior angle. Now we will correct the bearing. For bearing calculation we must require the angles also, so that is why we have corrected all the exterior angles. Now the corrected, now for corrected bearings, now for corrected bearing. So here, if the sum of both these angles are greater than 180 degree, we will subtract, and if it is less than 180 degree, we will add. For bearing of AB, so the normal geometrical mathematical calculation, we will now, we have calculated this fore bearing and back bearing. So we will start from here. So here corrected bearings, the corrected fore bearing of BC is equal to 192 degree 15 minute, and corrected back bearing of BC is equal to 12 degree 15 minute. Now corrected fore bearing of CD is equal to fore bearing of the previous angle, fore bearing of previous angle, that is 192 degree 15 minute, plus the station angle, that is angle C, minus, since this sum will be greater than 180 degree, we will subtract 180 degree, that will be equal to 192 degree 15 minute plus angle C is 216 degree 45 minute, 216 degree 45 minute minus 180 degree, that is 229 degree. This is 229 degree. Now corrected back bearing of CD is equal to corrected fore bearing of CD, that is 229 degree minus 180 degree, which is equal to minus 180 degree, that is 49 degree. Similarly, fore bearing, corrected fore bearing of DA is equal to fore bearing of CD, that is 229 degree plus angle D, that is 209 degree 15 minute minus 180 degree, which is equal to 229 degree plus 209 degree, 229 degree plus 209 degree 15 minute minus 180 degree, that is 258 degree 15 minute. Now back bearing of DA is equal to corrected fore bearing of DA, that is 258 degree 15 minute minus 180 degree, which is equal to 78 degree 15 minute. Similarly here, fore bearing after D, this is DE, sorry, DE. Now fore bearing of corrected fore bearing of EA is equal to corrected fore bearing of DE, that is 258 degree 15 minute. Fore bearing of DA plus angle E minus, if the sum of these is greater than 540 degree, we will subtract 540 degree, which is equal to, so fore bearing of DA here, fore bearing of DE, fore bearing of DE is 258 degree 15 minute plus angle E is 311 degree, which is 569 degree minus 540 degree. That will be 29 degree 15 minute. Now corrected back bearing of EA is equal to 4 bearing of EA, corrected 4 bearing of EA plus 180 degree, which will be equal to plus 180 degree, which is 209 degree and 15 minutes. Now 4 bearing of EA, AB is equal to corrected 4 bearing of EA, that is 29 degree 15 minute plus angle A. So angle A is 218 degree 30 minute. 29 degree 15 minutes plus 280 degree 30 minute minus 180 degree, which is equal to minus 180 degree, that is 67 degree 45 minute. Now back bearing of AB is equal to corrected 4 bearing of AB, that is 67 degree 45 minute plus 180 degree, which is equal to 247 degree 45 minute. Now 4 bearing of BC, this is for checking whether we have done the calculation right or wrong. So 4 bearing of BC is equal to 4 bearing of AB, 4 bearing of AB plus angle B minus 180 degree, which is equal to 4 bearing of AB is 67 degree 45 minute plus angle B is 304 degree 30 minute, 304 degree 30 minute minus 180 degree, which is equal to 67 degree 45 minute plus 304 degree 30 minute minus 180 degree, that is 192 degree 15 minute. So here we have the corrected 4 bearing of BC 192 degree 15 minutes, since we have calculated and returned to the same angle here. So this is right, checked. And also we will check for the back bearing of BC, that is back bearing of BC is equal to 4 bearing of BC 192 degree 15 minute minus 180 degree, which will be equal to 2 and 1 2 and this is 1 degree 12 degree 15 minute, 12 degree 15 minutes. So this is checked. So now we have corrected the 4 bearing and back bearing of the every line. This is all the solutions you have to do for the given questions. Thank you so much for watching my video. Please like and subscribe for further more videos. Thank you so much.